Hello, my dear students, and the rest of the learners. Welcome to part 10 in C++ computer programming series, in which we are going to learn about structures. My name is Memedi M, or you can simply call me Emily Swap. A structure is a collection of one or more variable types. It enables you to group data with various data types and work with it as a single group, thus making it easy to manage. Its difference with the array that we learned previously is that whereas in an array, you only hold data elements of one type only, structures allows you to add more information to your data. Therefore, each element, which is also called a member, in a structure can be a different data type. For example, if you wanted to store scores attained by a student in 5 exams using an array, you could only store the values, that is the scores, as follows, without indicating the name of the student or the name of the subject. Now, as we learned in part 9 of this series, we saw an array which contained of 5 values, that is 5 scores, 60, 40, 11, 18, and 95. And therefore, if you are keeping data in an array, that data must be of the same type. For example, 60, 40, 11, 18, and 95, all of them are whole numbers, or what we call integers. So, as you can see, in arrays, or as you saw in arrays, it would not be possible to tell a user whose results those were and for which subjects. Therefore, structures allow you to add more information to such data in order to make it more meaningful. Therefore, with the structures, we can add more information to our data. For example, we can enhance our data by adding the following information: student name, exams names, and the scores in each of the exams. For this reason, our structure can have some of the following members. We can have student name, and then the subject names, such as COM score for communication score, CAS score for computer applications score, SIS score for software installation score, Math score for mathematics score, and OOP score for object-oriented programming score. In other words, when we are making use of a structure, we are able to store or add information of various types. For example, identifying whose scores you are entering. And in that case, you can enter the student name so that the scores are per that student. And if you have several students, the same case will apply. It becomes easy to identify whose owner are the scores you are entering, which is different from an array. And therefore, we can have a structure that contains or is composed of student name and the scores attained in the 5 subjects. In this case, therefore, just as I have said, the COM score is communication exam score. CS score is computer applications exam score. SIS score is software installation exam score. Math score is mathematics exam score. And OOP's score is object-oriented programming exam score. Just as we said previously in this series of tutorials, we said that there are rules for naming variables, and it's always good to give your variables names whose content you can tell. In other words, it's always good to ensure that even the members of the structure can be identifiable. They can be identified easily. And therefore, when naming members of a structure, as well as the structure itself, it's always good to use variables or names for the members, that you can be able to tell what they are all about. This means that our structure will have 6 members per student in case we want to have scores for several students. Then, after having decided on the number of members that your structure will have, you must then decide on what type of data each of the members will have. For this reason, always determine the number of members you will have in your structure, their data types, and the range of data so as to ensure that your data types can hold both the largest and the smallest data values. Remember, in one of the previous presentations in this series, where we spoke about data types, we said that when you are identifying or when you are making a decision as to which data type to include for your members of your data, is always going to think about the size of the data. This is because if, for example, you are talking about integer, the numbers can vary from 0 all the way to millions, billions, or trillions. And therefore, it's always going to identify the data type that can be able to accommodate the type of values or the size of values that you are going to enter for your structure. Therefore, this information can be represented as follows. So we have member name and the data type. The student name, if you're entering names such as Julius, Meme, Jenny, Otieno, Kamau, Salat, Kipngeno, Kimgetich, etc., of course, the name will be composed of letters of the alphabet. That is purely characters. And therefore, the data type will be character or car, but car of array. For example, 20 characters. What we are saying is that it's important to note the name that we're going to key in for student name. How big is it? How many characters is it supposed to have? So that then, if the person with the highest name or the longest name is, for example, 20 characters, then the size of your character array for the name can be 20 characters. Then comes score. Of course, what you're going to store there is the score out of 100. And therefore, because it will not have in decimal points or fractions, it will be of type integer. The same applies to CS score, SIS score, math score, and OOP score. All of them will be of type integer. You can see when you are defining a structure, it's always important to know the data types for each of the members for your structure. Then, for identification purposes, you proceed and come up with the name of the structure. Now, the members in the structure will always inform you what you want to define. If, for example, you want to define or declare a structure for storing students' scores, then it means that the name of this structure will be student scores. And therefore, you are supposed to add a structure tag. For example, student scores structure tag. For this reason, each structure that you define should have an associated structure name that we call a structure tag. I repeat, each structure that you define should have an associated structure name, for example, or what we call a structure tag. In other words, for you to be able to identify what the members are representing in a structure, always give that structure a name depending on the content that that structure is expected to hold. And that name is what we are calling a structure tag. It's the one which is used for identification. You identify the structure that you have defined. Structure tags are not variable names, but are the labels for the structure's format. You therefore name structure tags yourself using the same naming rules as those of variables. For example, by naming our structure tag as student scores, you are informing C++ compiler that the tag that is called student scores looks like one character array followed by 5 integers. Why? Because our structure is going to have 6 members or has 6 members with one member being the name, which is character array, or the other 5 are integer types. For this reason, your structure tag is your newly user-defined data type that you want the programmer to define. This means that a structure is user-defined. It's the user who decides how or what will be stored. And for that name, when you define a new structure, when you define a structure that we are calling struct data type, that becomes your user-defined data structure. And therefore, that structure tag that you have given to your newly user-defined data type is what is going to be of importance to the compiler. This is because it is the programmer who is supposed to inform the compiler concerning the format for his or her structure by stating the data types for the members. So, whenever you are making use of structures, you have to tell C++ that you want a new data type, which will be your tag by a certain name, such as student scores. Therefore, when you define a structure, that structure becomes a new data type in the program, and it can be used anywhere, just like any other data type that can be used within your program. And therefore, whenever any other data type can appear, your struct can also appear, because your struct will be part of the data types that are in application within that program at that time. It is important to note that C++ does not reserve memory for a structure until you declare a structure variable. To define a structure, you make use of a reserved one struct, which defines a new data type with more than one member for your program. Its format is usually as follows. In other words, this is the format for declaring or defining your structure. You use the reserved one struct followed by the name of your structure, that is, the structure tag. And then under it, you define members. You define members while terminating each of the members with a semicolon. Or in other words, when you are defining members, you define the same way you define variables, or the way you declare variables. And if, for example, in one line, you are going to have more than one member who is of the same type, you separate each of them with a semicolon. But it's always good to have each member on its own, even though that may take space while coding. And then you close the body of the structure with closing parentheses. And then after that, or immediately after that, you give a name, one or more names for your structure variables. Remember, we are saying that for you to be able to make use of a structure or to be able to access the members of the structure and do anything with those members, you must have a variable that can be used to access and manipulate a structure. And therefore, it is good for you to always have an associated structure, a variable with your structure. So you have to have a variable for your structure, as you are going to see. For example, we can define our student scores structure as follows. The struct, which is a reserved one for identifying structure. What is the name of our structure? The tag or the name of our structure is student scores. And then you go to the body with the opening braces, not parentheses. It is opening brace, opening brace. And then under that, because that is the body of the structure, you define your members. Number one, car, student name, whose size should not exceed 20 characters. Then we have our next member, which is ComScope. Kindly note, these are not variables. These are placeholders. These are members for your structure. And therefore, you cannot even manipulate the member directly. You must pass through its structures variable, as we are going to see. Then we have the next member there, our next member, our next member, and our next member. So these members are going to hold data, which is a whole number, and that data will be of type integer. You can see that this list, the way these members are defined, is the same way you declare your variables in a program. And then we have the closing brace there and our variable for the structure. And in this case, our variable is student1. And then you terminate that with a semicolon. For you to be able to manipulate or access any of these members, you must pass through student1. You must pass through the variable for that structure. And therefore, the variable for student is called structure is student1. In this case, our structure or structure tag is called student is course. As you have seen, it's composed of 6 members, whereby one of the member is of type char and 5 are of type int. And we have one structure variable, or what we call object, called student1. Each member definition in the structure is a normal variable definition, including variable pointers if the structure requires a pointer as a member. We are going to learn about pointers in the next part in this series, as we are going to see. At the end of the structure's definition, before the final semicolon, you can specify one or more structure variables separated with a comma. In our case, we have just one structure variable, as you have seen, by the name student1. How do you initialize structures? How do you assign values to members? How do you assign, how do you store data in our structure? Now, that's what we call initializing the structures. Remember, you cannot use an empty structure, but you can store data in that structure. There are 2 ways of initializing members of structures. The first one is initializing members when you declare a structure. And secondly, is initializing a structure in the body of the program during execution. The syntax for initializing struct members during declaration is done as follows. So you have the struct, which is a reserved one, followed by the structure tag, and then under it, we have the member definitions. And then after the definitions, we have the closing brace, and then we have our structure variable or variables. So it is in that structure variable that you assign or that you enter or allocate or store values. So if, for example, your structure tag or your structure tag is student is course, but the structure variable is student1, it is now in student1 where we assign the values. And therefore, we put an equal sign and then opening brace, we list our values in the order as they are, or in the order of our members, beginning from the topmost member to the one who is below, in that order. And then we terminate that, or we include a closing brace and a semicolon. The braces must then close the data you initialize in the structure variables, just as the enclosed data when you initialize arrays. The following is therefore an example of a structure declared and initialized at the same time. So we have our structure whose structure type is student discourse. Then we have the opening brace. We have our members as follows. These are our members, or the members of the structure by the name student discourse. And then we have the closing brace. Then the variable for this structure or structure variable is student1. You have equal sign. We have the opening brace, as you can see, and then we list our members in that order, in the order they are in the structure, from top to the bottom. For example, meme, and because this is a string is an array of characters, we enclose them in double quotes. So meme goes to the first member, who is student name. Then you have 60, that's integer. It goes to second member, who is com score. 40 goes to S score. 11 goes to SIS score. 18 goes to math score. And 95 go to OOP's score. Then we close that initialization of that list with a closing brace and a semicolon. So that's how you initialize the members of a structure directly within the code. Note that the data for array of car is normally enclosed in quotation marks, just as I've said. The values in the initialization list are usually arranged in the order of the members in the struct, just as I have explained. You cannot initialize individual members directly inside the structure definition because they are not variables. In other words, you don't initialize members directly. You initialize members through the structure variable. The only structure variable for our student or for our structure, the only structure variable for our structure in this case is student1. This method of initializing structure variables, as you have seen, becomes tedious when there are several structure variables. Putting the data in several variables with each set of data enclosed in braces becomes messy and takes too much space in your code. Therefore, a better approach to initializing structures or members of structures is to use the dot operator. How? The dot operator is a one way to initialize individual members of a structure variable in the body of your program. With the dot operator, you can treat each structure member almost as if it were a regular non-structure variable. The format for the dot operator is as follows. The structure variable's name, dot, member name, and a semicolon. For example, our variable name or our structure variable name, as we have seen, is student1, and our member that we wanted to access is student name. And therefore, for us to be able to access that member, we pass through the structure variable. And in this case, our structure variable is student1. So we write it as student1 dot student name. And once you have done that, you can assign the values to student name using an assignment operator within the code. Another example is to access the member code CAS score. We write it as student1.CAS score. In other words, for you to be able to access any member of our structure, always pass through the variable name. And in that case, is student1, then dot member. Well, the format for initializing members using the dot operator is as follows. Structure variable name dot member name equal to value semicolon. For example, if you want to initialize student name, that is member by the name student name, passing through student1, you do it as follows. Student1 dot student name equal to Otieno. And you can see it's enclosed in double quotes because this is a string. So what statement is simply saying is that pick the value or the data, pick what has been entered. That is a string of characters by the name Otieno or content Otieno, assign it to a member of the structure who can be accessed through the structure variable by the name student1. The second statement here simply means assign 100, the value 100 to a member called CAS score who can be accessed through student1 variable. Note that When initializing an array of car that is string member, you should always enclose the value you are assigning in quotation marks, as you have seen. In addition, when assigning an array of car or string value to a member of a structure using the dot operator within your code, it is going to copy your value to the member using a string function, such as string cpy or string cpy underscore s, instead of directly assigning the value like other types. Why? It is because the value, the size of the value or the number of characters that you wanted to assign to the member might not be exactly equal to the size that has been defined. And therefore, to allow the data that is entered to be held as one set of characters, it's always good to use the function for copying the string to the member. And in this case, this function can be either string copy or string copy underscore s for safe way of copying. This is because when initializing an array of car with a value, just as I've said, the value that we assign it to the member may be less than the size of the array. Yet, the rest of the characters cannot be initialized to 0, as it happens for other data types in arrays. In addition, if you make use of functions for manipulating strings or array of car, you may need to include the string file that contains such functions as preprocessor directive, depending on the version or the type of C++ compiler that you are using. The preprocessor or this preprocessor directive can be included as follows: #include string.h or as #include string. It depends on the version of C++ that you are using. Therefore, a structure variable name must always precede the dot operator, and a member name must always appear after the dot operator. We can therefore initialize our structure members through its variable as follows. You can see we are copying Otieno to the member called student name, who is accessible through student1. And to copy that, we use the function string copy that as safety or security measures. Then to assign 60 to comscore, we do it as you can see. The same applies to CS score, SIS score, math score, and OP score. So that's how we assign. That's how you can initialize members of a structure using a statement and an assignment operator. Once your structure has been initialized, you can then display the values from the structure through the structure's variable as follows. You just write out. For example, this statement means write out the content of the member called student name, who is accessible through the variable called student1. This is student1. Then the next statement reads or says, write out the content of memory, not memory, write out the content of the member called student comscore. Write out the content of the member called comscore, who is accessible through the variable student1 on the screen. The next is the same. The cout student1.sis score, via format score, and via for OOP score. So that's how you write out. The most important thing to remember is how you access the content of a member. It is the structure's variable name dot the member who is of interest. You can assign content to the member. You can write out the content from the member and perform any other operation as long as you have student, or as long as you have the variable name, the structure variable name dot member. The following is therefore an example of a program implementing a structure and initialization of members. So we have a file name there, and this program indicates or demonstrates how to initialize members of a structure at the declaration and in the program. So we have the first statement as usual for C++ programming. We have the second one using namespace standard. Then we go to the main program, the main function, int main. And then, of course, we proceed as follows. Then we define our structure. In this case, it's struct student scores. Then we have the body for that structure. We have car, student name, size 20. Then we have our next member there, our next member, our next member, our next member, and then here we are assigning values into our structure through the variable called student1. This is what we are going to look into, but in a program. Once you've done that, you can then display the values from this structure. You write them out using the output statements, just as you have seen. So, see out. This message will be displayed on the screen. The current values in the members of the structure called student scores are. So that statement will appear on the screen. And the cursor will blink on the next line. Then the next statement is for writing out content of the member called student name. Then followed by com score, CS score. This is one line with the spaces separating each of them. And then once we are through with writing out the values of each of the members, we are requesting the compiler to drop one line on the screen or write out a new blank line. Then we can modify some values, or this program is also modifying some of the members of the struct so that we are able to see what happens. So we can modify by copying a new name like Otieno to the member called student name. Then we can also change the value in the CAS score. From there, we can display the updated structure for the purposes of showing you that you can always alter the contents of the members of a structure using statements on the screen, like the way we have seen here. And then this part is for showing us the changed structure. So to display the updated structure with amendments, we are going to write out a statement that reads, for example, and now these are the current values of the modified structure, and then the cursor will move to the next line. Then this is writing out the members. Each of the member, like student name dot student1, then we have space. Next value will be displayed, which is stored in com score, the one which is stored in CAS score, the one which is stored in SIS score, the one stored in math score, and the one stored in OOP. So that's what is going to be written out. And then that will be the end of our program. We turn the control back to the operating system and end the program. So having looked at a program, which you can also copy in your exercise books, or write down on a piece of paper, or type, for example, in Word or any other editor, then from there, you can copy that program to your C++ or type it directly the C++ editor and then run it. So after you run, how does the output look like? So let us load C++ program in our computer. We code the program that when displayed as it is, we compile it and execute this program so that we can see how the output will look like. So what we are going to do is we are going to start C++ program. I already have it open here. So what is the name of our program? Let's look at it. Let's look at the name of our program. Our program has the name struct init dot. That means it is for a structure, but indicating how we initialize at declaration or at definition and using the dot operator. So we are going to call it struct init dot program. The name is struct init dot. So let's proceed. So we start our C++ program there. We click on File, New, Project. Remember, I'm using Visual C++ 2010, as you can see. If you're using another version, what is important is to load the editor, to load your C++ program. Once it is ready for you to enter the code or type the code, you proceed. But for 2010, we proceed as follows. So the name of my project is struct init dot. Struct init dot. Then I click OK. You can proceed. I discussed and demonstrated this previously. That's why I'm not taking time really to explain the procedure. Then, new item. We want to develop code, C++ code. So we type the name as usual. Our name is struct init dot. Remember, you can use any other name as long as you're able to remember what it is doing. Then I'll click on Add. So once you are on our editor, for us, we are just going to copy our program and paste it here because we have the program with us. So just move to the program. Our program that we are coding is this one here. This is the program that I have demonstrated. This is the program. So if you have written your program or you have coded it like mine, you can just copy your program. I'm copying my program because it's already ready. I want you to see how we can execute it. So for you, you can just copy it or just write it. But what is more important is for you to understand how the process is done. So I'll copy my program. And then I'm going to paste it in my editor like that. That is our program. If you are writing it directly on your screen or on your editor, that is C++, you just need to write sentence by sentence, just as I have demonstrated in this program. So you can move through each of these statements one at a time as you copy each of them, then you read it and understand what is required. So if you copy this program, like mine, and you are able to understand the logic of how it is working, then you can just proceed, copy it, copy your program in C++, like this. And then once your program is ready, because our program is now here, of course, you save your program. And then for Visual C++ 2010 compile, we click on build and then click on build solution. However, for other versions, you may just have compile. Let's see if our program will compile successfully. Good. You can see that our program has no error. Compilation has been successful. And therefore, our program, our source code has been converted to object code ready for execution because it has no errors. Now, to run our program in C++ 2010, we click on debug, and then we click on start without debugging. So let's see. Good. Now you can see from this output screen the members of our structure. These members of our structure have been displayed. And which statement is this? It is this statement here. So you can see the current values in the members of the structure called student scores are. You can see that's the statement. And then we drop one line below. Then you can see the members just as initialized are here. Mem 60, 40, 11, 18, 95, just as they are in our structure initialization. And then there's a small amendment here. There's a modification. Let's see the modification. We have modified the first value, which was Meme to Otieno. And then we have also modified the value for CAS score 100 using the dot operator. And therefore, the statement which is here now, which says, and now, these are the current members of the modified structure. You can see the first value has been changed using this statement here. SDR CPY underscore S, that is, copy the string safely. Copy Otieno to member called student name, who is member or who can be accessed through the variable student1. And you can see the members have been displayed out using the cout statements here. And you can see a name has changed to Otieno, 60 as made as 60, but CAS, that's the value I changed from 40 to 100, and the others have remained. And then that is the end of that program. So that's how this program works. To go back, you press Enter key on your keyboard. So that's how we can be able, that's how our program is behaving. That's how we initialize our structure directly and using the dot operator. In addition, by using the dot operator, you can receive structured data from the keyboard using the data input function, such as cin, instead of initializing the structure at declaration. You can thus prompt the user to key in data and have it stored in the structure from where it can be manipulated accordingly. In other words, my dear students and the rest of the learners, we are saying that other than initializing the members within the code at the coding time, you can also prompt the user to enter values into the structure, and you do that using the dot operator. Once you have entered the values into the members of the structure, you can perform various operations with the values from those members, just as you would have done with the variables. For example, you can copy the members of one structure variable to the members of another by just making use of the assignment operator, just the way we assign other values. For example, you can copy the structure or members of the structure called student scores to the structure called student scores using the assignment operator. But both of the structures must have the same format. In other words, the members must be the same and organized in the same manner. However, always remember that for you to be able to access a member of struct, you must pass through that struct variable, just as you have seen. Therefore, if, for example, we wanted to compute the sum for the various scores that we have entered into our structure and also store the sum into the structure itself, we could do it as follows. So the first thing is to include a new member, the struct, for holding the results. So in this case, what we are doing is we are just adding this member here so that this member can hold the total for the values that are entered. And our variable for this structure is student1. This structure is the same one, like the one I've demonstrated, called student scores, but now we have added an extra member who is sum, who is expected to be used to hold the sum of the values in the structure. Then we prompt the user for the values and read them in the struct using the cin function. For example, if you tell the user to key in the student name, whatever is entered is picked and stored in the member called the student name, who is accessible through the structure variable called student1. The same applies to COMScore. So these statements are for the cin. Whatever that is, if you want to enter, for example, OOP score, you request the user to enter the score in OOP, then that value will be picked and be assigned into the member called OOP score who is successful through the variable called student1. Then we compute the sum and assign the results to the member called sum using an assignment statement as follows. So you can see the way we are manipulating each of the members, as long as we have the dot operator and the variable for the structure, is the same way we would have done for other variables. How do we read this statement? We read it as follows. Beginning with the last part, read whatever has been entered into the member called OOP score, who is accessible through the variable student1. Read that value and to whatever that is stored in the member called math score, accessible through student1. Then and to what is SIS score, what is in CAS score, what is in COM score. The total or the cumulative sum added to or assign it to the member called sum, who is accessible through student1. In other words, student1 is the common variable for the structure. Then the rest are members. Then you display the values of the members from your structure using the C IDE function. For example, the following is a program implementing a structure that is initialized by requesting the user to enter values, and then it computes some of those values and displays the results on the screen. So this is just a modification of the program that I've just illustrated. Its name is struct user init sum. That's a name showing that it's a structure that allows the user to enter values to initialize, that is user initialization, and to compute sum. Then it demonstrates how to initialize struct through user entry and also compute sum from the members. Then we have the hash included of stream.h or just our stream using namespace. We got the main there. Then we have the definition for our structure, the one we have just talked about, and using the same syntax we have already discussed. So that's the structure. Now this structure has 7 members. One member is of type curve array, and the 6 members are of type integer. The variable for that structure is student1. Then we prompt the user to enter the data. So this statement will display on the screen, enter data in the structure. Then it will indicate the name of the student, or in other words, it will indicate what the user is requested to enter. So the first entry is student's first name. So student's first name will appear on the screen, allow the user to enter whatever will be entered, be read and stored in the member called student name dot, who is accessible through the member student1. That is student1 dot student name. Then the user will be prompted for communication score, and the value that will be entered will be stored in the member called com score, accessible through student1. And the same will continue for computer application score, software installation score, then mathematics score, student1, that's mathematics score, object-oriented programming score. And that will be what the user will be requested to enter. Next, we compute the sum, the total for the scores using the same statement that we have discussed. And all the values, the total, the cumulative sum, will be stored in the memory location code or in the member called sum, who is a member of the structure. Then we display the values from the structure. So the message, the scores for whoever has been entered. For example, the scores for John are, this statement simply means read or display the message, the scores for, pick the value or the content in the member called the student name displayed on the screen. If you have entered John, it will say the scores for John are as follows. Drop down, cursor one line, and then display communication scores. Pick the value stored in memory location code or in the member code, com score display on the screen. Display the message, the name computer applications, followed by the content in memory location or in the variable in the member called CS score. Display the name or the message software installation followed by the content of the member called SIS score. Do the same for math score. Do the same for object-oriented programming. And then drop down or write out a new line. Then display the total. So the message to be displayed will be whose total is, pick the content of the member called sum and display it on the screen. Then write out a new line, return the control back to the operating system, and end the program. Now, how will that program look like if we code it in C++? So we are going to proceed as follows. Remember, our program name is struct user init sum. Struct user init sum, but you're free to give it any other name. So we are going to start C++. Let me close this program first by clicking on close solution. And then we start afresh. File, new project. This Win32 console application. Our project name will be struct user init sum. Struct user init sum. Click OK. Then proceed. Then right-click on source files, point on and click new item. We are writing a code C++ file. The name of our program will be user init sum. Then click on and. Now, just the same way we have done before, you can type your program directly here. But if it is available, like in my case, I have my program here, I can just copy this program and paste it on my editor. So just copy my program. For you, my dear students, and the rest of the learners, you are supposed to write this program in your exercise book, for example, or you can type it directly on your editor, but it's not advisable. Always write your program on a piece of paper or on an exercise book or in any other editor. Go through it, check it out, then you can always paste it on your C++ program editor. C++ editor. We call it the integrated development environment. So here is my program. You can see file name is struct user init sum, and my structure is here. Then we prompt the user for the values and we write them out, as you can see, and also computing scores is here. So you click on save. I have saved. To compile our program for Visual Studio 2010, you click on build, then click on build a solution. If your program has errors, those errors will be displayed at the bottom of the screen. But if there are no errors, the program will just tell you success. Good. You can see our build has succeeded. So our program has been converted to object code. We can then proceed and run our program. For some compilers, you can just click on run, compile, then run. Compile, compile instead of build solution. Others are, instead of debug, then start without debugging, may have a compile, then run or execute. So it will depend. But for Visual Studio 2010 C++, you click on debug, then start without debugging. So this is running our object code. Good. This is our output screen. Which statement is this? Let's see. This is where we are. So this is the statement that you can see. It is displayed on the screen, and then student's first name, then enter student's name. It is red. So I can type, for example, Meme. I press enter. You can see the next statement is computer application score. The next statement is communication score. The next one will be computer application score in that order all the way. So I can enter, for example, 45. Next is computer application score. I can enter with the 4. Next is installation, software installation. I can enter 23. Mathematics score, I can enter 78. Object-oriented programming, I can enter 21. Now, what did we expect to see once I press enter? We expect the computation to be done, then the message, the following statement to be displayed. The scores for example, are as follows. Then we are going to have communication skills, computer application, software installation, etc. So let me display this part, and then I can place my screen here so that we are able to see. Let me press enter. You can see that work is done very fast. We are told the scores for meme are, that is, this statement here. And then the others have been listed in their order. And we can see whose total is whatever is in the memory location called sum. And that's whose total is 221. So that's the output. So we press enter, take the control back to the operating system, and that's where we're able to come back to our program. So that's how you compile and execute our program. Now, if you are going to work with several students, for example, or several records, you can always have what we call array of structures. An array of structures stores several values of different types together. They are thus used to store many occurrences of your data values. Therefore, many C++ programmers use array of structures as a prelude to storing their data in a disk file. You can thus input and calculate your disk data in arrays of structures and then store those structures in memory. Arrays of structures also provide a means of holding data that you read from the disk. To declare an array of structure, you specify the number of reserved structure inside array brackets where you declare or when you declare the structure variable. Therefore, its syntax is as follows. It is structure tag, and then the body is the same. What only makes the difference between an array of structure and a single structure is just the addition of the size part in this statement where we have the variable name, then size. So if, for example, the variable name was 21, then you can be able to say, or student, then you can be able to say how many records are you going to have. So you enclose that in square bracket. And then the same rules of arrays apply. So, for example, if your data in the following format to be stored in a structure, that will definitely be an array of struct so as to be able to accommodate data for the 5 students. It's an array of struct because the fields or members for each record or struct are similar. In addition, the type of data to be stored for each student is similar, as you can see from this table. So in the case we have dealt with, we had only a single record for a single student, like meme, 60, 40, 11, 18, and 5 for each of the subjects. But now we have additional members. We have additional rows or additional records. So in this case, because the details for one record are similar, except the content, the type of members are the same, then this is an array of structure. So if you wanted to store this kind of data in our structure, it means that we would have 5 records. Meme, Otieno, Wangoi, Chebet, and Wambua. So that becomes an array. So in this case, each of the headings or fields become the members of the structure. In other words, com score, CA score, SI score, math score, OP score, sum, just as you have seen, those are the members. We can call them the headings. And then, of course, our structure will be declared as follows. Note All other members are the same. But now, the last variable, structure variable, is the one which is now an array. So we enclose the array size, the struct size there. The array size is 5. That's the difference. Otherwise, once you have known how to develop or how to come up with a structure for any data, it becomes easier to manipulate the array tool, because the rules of array, as we learned in our previous presentations in this series, apply. Therefore, in one quick declaration, you can see 5 student structures are created, with each structure containing 7 members, 1 member being of character type, that is char of array, and 6 being of type integer. Each individual structure variable would be as follows, because the rules of array still apply. So where we had student 1, we can change it to students. And then the first student is identified by subscript 0 for index, as we learned in arrays. The second student is students who we enclose one in square bracket, that is index 1. Why? Because as we said previously, each member of an array is identified by the position, that is the index. And the same also applies to the struct of array. The first struct for the first person or first information is index 0. The next set is 1. Next one is 2. Next one is 3. And next one is 4, meaning these are 5 structs. So it's an array of struct because it has 5 structs, and each of the struct contains same type and number of members. Therefore, because each of these is a structure variable, each will contain 7 members, each of which can be referenced using a dot operator, just as we have learned. The dot operator works in the same way for structure array elements as it does for regular structure variables. To access and manipulate any member of the array of struct, you still make use of the dot operator as you have learned. For example, if you wanted to assign some values to the first student in the structure, you would do it as follows. Just copy, for example, the name Meme to student name member. Member of which record? Of student 0, meaning the name of our structure is students. The name of our variable, the name of the variable for the structure is students. The first record is student 0. Then, if you wanted to assign, for example, 40 to the member called CS score for the first student, it will be done as follows. What about if you wanted to assign to the student whose index is 3? You do it just as you can see. The only difference, my dear students, and the rest of the members or of the learners between this statement or how we do it for array and how we are doing it for the normal member for abstract is that we now include the subscript. And the subscript is usually on the variable, like the variable called students. Generally, you can manipulate the array of struct just as you manipulate other variables in the arrays. In addition, because you perform similar tasks for each structure variable in the array and repeatedly, you can always make use of the for loop, just as we learned in the topic for arrays. And my dear students and the rest of the learners, if you have not gone through the part in this series in which we talked about arrays, I kindly advise that before you proceed with learning about the struct of arrays, that you go back to the array presentation in this series. You are going to see it from the title, and then you can be able to now proceed with this section very comfortably. The only aspect you need to remember is to ensure that you remember to indicate the index for each of the members. The following is the other program implementing an array of structures. It is similar to the one that we have looked into for computing sum, but now accepting and manipulating data for 5 students. So our file name, our program name is array struct user init sum. You can always come up with yours. It demonstrates how to initialize array of struct and compute sum for each student and compute overall students total. Then we have the outstream. We have our manip because of the function for spacing using namespace standard library. We have our main function there. And then we now declare or define our structure. Our structure is still called student scores, and the members are the same ones that we have discussed in this presentation. But now, as I have said, you can see now the structure variable is now students, and it has several students. It has 5 records. The first having all the 7 members, the second having all the 7 members, the third, the fourth, and the fifth. And then, of course, for the purposes of the for loop, we have to have the control, the counters. So I'm calling it the variable student num. And then because we are also going to display the total sum, we have the overall sum variable. And then we initialize it to 0. And then we prompt the user to enter the values. Note, because now we are going to enter for several, we are using the for loop. So for student num, so let me remind you what we talked about this for loop. It says this way. Now this statement, it states that pick 0, assign it to the variable called student num. Then check if the content of the variable called student num is less than 5. If yes, like in our case, yes, student num contains 0, we move on. Then we execute the following statements. We display the message student number, then we repeat the value in the student num. If it is 0, it will be student 0. Drop down one line, then prompt for the user to enter the student name. Pick that value, store in students whose index is 0, the first one. And do the same for communication score. Proceed all the way. Then once you reach that statement there, once you reach this statement here, compute the sum, calculate the total score. Pick what has been entered as OOP score 0, add what is in mass score for student 0, then SIS for student num 0, CAS score for student num 0, com score for student num 0, sum score for student. Then assign the value, the sum, to the variable called sum for student 0. Then compute this total. Pick what is in sum for student 0 and add it to what is currently in the memory location called overall sum, and the results you get, assign them back to the memory location called overall sum. Then drop down or write out a new line, and then once this symbol is reached, increment the value of counter, come back here to the last section, increment the value of student num, whatever is in memory location called student num, increment it with 1. Then check so in this case, it will be 1. 0 plus 1 is 1. Is 1 less than 5? Yes. So do the same. Pick what will be entered by the user, assign it in the member who is student 1. Do the same. Com score for student 1 and all the others for student 1. Then calculate sum. Pick what is in OOP score, student 1, and to math score, student 1, all the way, and the cumulative sum or total, assign it to the memory location or the member called sum for student 1. And then calculate the total score. Pick what is in sum, and it to whatever that was. In other words, pick what is in sum for student 1, assign it to or add it to whatever that is currently contained in overall sum. Then total, store it back to overall sum. Write out a new line, then go again, increment the counter. So the counter will increment from 1 plus 1, it becomes 2. Is 2 less than 5? Yes. So continue that way until repeating that process until when the content of student num will no longer be less than 5. So when it reaches 5, this section will be skipped, and we are now going to display the results. So displaying the current values for the struct inclusive of sum. So this message will be displayed on the screen, and then these headings will be displayed on the screen, spaced as follows. So num, space of 12, name, space of 15, score etc. So these will be the headings that will be displayed on the screen. And then from there, we are going to read the values now using the for loop control. And I will inform you how it will work. So initialize the student num memory to 0. Check if the value of student num is less than 5. In this case, is 0. 0 is less than 5. So it will move on, display these headings, then display the content for each of these values for student num 0. When it reaches here, it will increment student num with 1. So 0 plus 1 is 1. Then check, is student num less than 5? Is 1 less than 5? Yes. Repeat this process. Pick whatever that is for student num 1 all the way. When it reaches here, to increment counter, increment student num with 1. So 1 plus 1 is 2. Is student num less than 5? Yes, 2 is less than 5. Proceed as follows, writing out the content for each of the indices. And then once student num is no longer less than 5, skip all that and write out that the cumulative total for all the students is, pick what is in memory location called overall sum, display it on the screen, and drop down one line. Return control back to operating system and end the program. So the following is a demonstration of how this program will work. We can therefore progress as follows. Let's start our C++ program by first closing our current program by clicking on Close Solution. And then, as usual, we move to New. We click on Project, click on Win32, Win32 console application, and then we type the name of our project being array struct user init sum, and then click OK. Then we click on Next as usual, click on the console application, empty project, and click on Finish. From there, we right click on source files, point on and click New Item. Then, because we are writing a C++ code, that source code, we click on the code C++ file. And then the name of our program will be array struct user init sum, meaning it's an array of structure that is being initialized by the user and it computes sum. Then click on Add. Once we are on our editor, we can type our program. But because my program is already ready, just as I have demonstrated, we can just copy our program and then we paste it under our editor. So I'll select my program. That way. Then click on the copy. Open my editor, and I'm going to paste my program there. So that's our program. As usual, you save the program. Remember, this is the same program. This is the same program that I have demonstrated on the screen, and therefore, you can just copy the program as it is from the screen. That is, this program that I've already demonstrated here, this program. So you can just write this program as it is, just as it is, and then you can type it on your editor. That is in C++ program IDE, or Integrated Development Environment, here under the editor. So you just type your program. After typing it, you save it, and then you compile your program for Visual 2010, that is Visual C++ 2010. You click on build, then build solution. Let's see if our program has any errors. If it has no errors, it will say success. Good. You can see at the bottom here, our compilation has been successful, meaning that our source code does not have any syntax errors. We can then run our program or execute our program by clicking on debug, then start without debugging. However, if you're using other versions, you may have to click on compile, then execute or run, or you may have other options. But for Visual C++ 2010, once your program has no errors, you click on debug, then start without debugging. But if it has errors and you don't know where the errors are, you can always click on start debugging so that you are taken through your program as you rectify the errors. So because our compilation has been successful, I'll click on start without debugging. Good. So this is our output screen. Let's see which part of our code has been or is being executed for now. So the part which has been executed is this section here. It's prompting the user to enter the details. And we are now entering in student whose index is 0. So I can type name, for example, then the scores. You can see is the order that they are listed in our code. Once the first set of record is entered or the first student is done, next is to increment student num to 1. And therefore, the current num or index is 1. So I can type the details. Remember, each of these values is being entered into the respective member. Then once the second student is done, that's index 1, index is incremented to 2. Is 2 less than 5? Yes. So we enter the next student's details. Remember, each of these details are being stored into the structure. Then it's incremented again to 3. So is 3 less than 5? Yes. So we type another student on details for the next person. Then we can key them in that order. You can see after object-oriented programming score, the counter is incremented to 4. And now we type another person like Jane. And then we key in our scores like that. And remember, this was the 4th index. That's a 50th student or 50th record. Once that is done, you can see that what we had entered has been displayed on the screen. You can see that. Which part of code is this? It means that already the section for accumulating or computing sum has been done, and what we are now seeing are the results displayed. And you can see this is the part here. This part where we have the C out is a section which is displaying the values that we have entered. And as you can see, if you scroll on this screen, on the output screen, you can see we have all the information we have entered, and that's the same information that is output here. The work of set W, this set W, which is part of the output statements, is for spacing. As you can see, that's what has given us the spaces in our output. so that our data is well organized. And you can see the last statement is the cumulative total for all the scores is. And that's the last statement here, where below it, it reads press any key to continue. So you can see that the accumulated total for all the students in our case is 1167. So that's all. That's how our output will look like, and that's how our program is going to behave. So you press enter to go back to your, or to take the control back to the operating system, and then we go back to our program. So the next action we can take is we can break down our program into functions. And then we can pass a structure or array of structure to a function. How do we do it? Structure variables are passed by copy. Therefore, if you fill a structure in a function, you must return it to the calling function in order for the calling function to recognize the structure, or using local structure variable, which is generally not recommended. A good solution to the local or global scope problem is this. Define your structure globally without any structure variables, and then define all your structure variables locally to the functions that need them. As long as your structure definition is global, you can declare local structure variable from that structure. The structure tag plays an important role in the local or global problem. Use the structure tag to define the local structure variables. The structure tag keeps you from having to redefine the structure members every time you define a new structure variable. Before a function name, you must declare void or put the return data type if the function returns a value. And if you forgot about functions, I kindly advise that you go back to the presentation in this series that I explained and taught about functions, so that you can be able to remind yourself about what a function is, how you develop a function, how you pass argument to a function, how the function receives parameters, etc. Before a function name, you must declare the return type. If it's not returning any value, you use the return type void. But if it is returning a value, ensure you indicate the data type of the value that the function will return. For example, if you have a function called getData in the following program, and it returns a value, then it means that that value will be struct value. So getData function in the following program does return a value, and the type of value it returns is struct student scores. Remember, then structure that you have defined is already a data type by its own. So the return data type for a function implementing struct is usually struct. Other than if it's not supposed to return any value. Because structured data is nothing more than regular variables grouped together, you can perform computation using structure members, such as in the function called compute_sum in the program that follows. As long as you use the dot operator, you can treat structure members just as you would do for other variables, even when making use of functions. Therefore, the following is a program implementing passing of structure to a function. The student discourse structure is defined globally with no structure variables. And then in each function, local structure variables are declared by defining to the structure tag. It makes use of three functions, one for receiving data from the user, the other for computing total, and the other for displaying data from the structure. And of course, that's how functions are developed. Each function is supposed to perform one function or one activity or one task. So our function is called, or our program is called struct function. It implements passing of struct to functions. As usual, the rest of the statements remain. Because this is implementing functions, it's always good to prototype your functions. And of course, this is the first function. Its return data type is struct. So struct student scores. That's the data type for our function that is going to be returned. The function name is get data, and it is receiving data, or it is receiving a variable. It is receiving a structure variable called student1, which is of type struct student scores. A prototype, you terminate it as semicolon. The next is the function for computing sum. Its data return type is struct student scores. The name of the function is compute sum. It is receiving a variable called student1, which is of type struct student scores. The rand function is for displaying the results. It's called display data. It's not returning anything, and therefore it is receiving one parameter called student1, whose type is struct student scores. Then, because we have said it's always good to declare our structure globally, but then you define its variables or declare its variables locally, then we bring our structure out here. So we define our structure. The struct student scores. It has the following members, the same members we have been using, and it has no variable for now. So no memory that has been reserved for it. Memory for structures is reserved once you define or you declare its variable. So we go to the main program, and then at this point, we declare a variable called student1, which is now of type student scores, and we're initializing it. The string, the character part or the string part, we're initializing it by cleaning it. So that's why we are having just the opening and the closing of marks or quotation marks. And then all the other members of the structure, because they are integers, we're initializing all of them to 0. Always ensure that you define and initialize your local variable, so that in case there's anything inside, it can be cleaned, and also that will help make it possible for you to receive accurate data as you proceed. Then we have core functions. The first, that is core statements. The first core statement is calling or invoking the function called get data, and it's passing to it the variable called student1. That's a structure variable called student1. And this function is supposed to return a value which is of type struct that is supposed to be stored into the variable called student1. Then, once this statement is invoked, once that first statement is invoked, the first function, the program, the compiler will go to the prototype at 1 and then look for that function after the main. So that's our function. That's our function for getting data. So its return type is struct student scores, and it's receiving one parameter which is of type struct, and it's called student1. Then it is wait from the user to enter the data, the values. So this part of the function is just the same as what we have done in this presentation. So there's nothing unique. You say that now we are treating this as a function of its own, a function for accepting input from the user. And therefore, it is returning the variable. That means it's returning all the members to the calling or invoking statement. So once return student1 is invoked, the compiler will now go back to where it had left. It has brought back some values. So those values will be assigned to the memory location or to the variable, the structure variable called student1. And that will be done. Then it will proceed to the next core statement. The next core statement is for invoking the function called compute sum. And it is passing to it one argument, which is student1. That is the variable called student1. So once compute sum has been invoked, that function, the compiler will go and look for that function or that function prototype. Here is the function prototype. Then it will go now after the main program and look for that function. So where is that function? It will look for it. Here is the function, is for compute sum. So this function is supposed to return data of type struct, and it is receiving one parameter, which is called student1, and it is of type struct student scores. Then it will do the computation. Remember, these are the members of the function of the variable called student1. So it will pick whatever is in student1 OOP and do what is in the member called math score and what is in SIS score, etc., and assign that value of the result to sum for student1. And then you return again. Remember, these values are being read from the function. They are being read from the variable. And then after the addition, because the member called student1, the member called sum, will have received a certain value. Then this function is being told to return the members. It is told to return the value, the variable called student1 back to the invoking statement. That is back to main. So here it is. So it will come here and then assign now the results that it is carrying with it to the variable called student1. That will have been done. Then it will proceed and execute the next call statement. The next call statement is for invoking the function called display data, and it is passing to it the function or the variable called student1. So it will pass the members of student1, the function called display data. So once that is invoked, it will go to the function prototype. Here it is. And then after the main program, it will go and look for that function for displaying the results. So here is the function. It is not going to return any value, but it is receiving one parameter called student1, which is of type struct student scores. So it will display that statement on the screen and now display the values from each of the members, just as we have done before, like that, and also display the total. And it will write out one new line and return back to the calling statement. So this function's work is just to display the results of the data in the members for the structure that we are only dealing with, which is accessible or who are accessible through the variable called student1. So once that is done, then it means that the control will be taken back to the main program where it will now proceed. So the next thing it will do is it will execute this statement, which requests the control to be taken back to the operating system, and the program will end. So that's how this program is going to work. So let's see. Let's load a program, or let's load C++. We paste our code there. We compile it and execute it as follows. Remember, you can also copy this program, write it down in your exercise book as it is, so that as I demonstrate how this program will behave, you can also be able to follow in your computer. Or you can also be able to see how the program is going to behave. So what we are going to do, we are going to start our C++ program. Then if you find out that your program is still open, close it. Then that is, if you find that your source code is still open, close it, close that program. But I've not closed the C++ whole program. What I've closed is the program that we're executing, not Visual C++. So from there, let's begin our new project. What is the name of our program? The name of our program is, remember, you're free to give yours, but I'm preferring to use the ones I've used in my program, because that's why we give this name as a comment to help you be able to trace your programs even in your storage medium. So our program is being called struct function. And therefore, I'll go back to my program, call it struct function, struct function, and then click on OK. Of course, I'm going to proceed as usual. Then let me start new source code. I'll click on the code, C++ program, and then under name, the name is struct function. Because there's a program that is indicating how to break down your program to functions. And because we have learned about functions, and we also know about how the functions work, we are just going to copy our program. Our program is this one. So if you have copied your program, or you have already coded your program, or you have written it somewhere, you can just copy it. Remember, this program is the same one that I've been using in my demonstrations in this presentation. And therefore, the only difference is that now we have broken it down into specific functions or parts. A function for inputting or accepting values, a function for computing the sum, a function for displaying the results. Otherwise, it's the same program, but now this program is modularized. Then you can save your program. Then we compile our program. Let's see if there's any errors. Our struct function is still being compiled. It has no errors. So if you copy this program as it is, and then you code it in your program, in your editor for C++ and compile, it should not give you any errors. If you find any errors, you can always run each line by line as you compare my program with your program. Then you can run your program, and in our case, we are going to click on debug, start without debugging. So I have executed my program. Now what you see is that this output is similar to the other output we have already dealt with. The only difference is that in our code, we have broken down our program into functions, but it's the same as the other one. Therefore, I'll just enter my values, find it in my program or into my structure. As you can see, this is for a single record. That's why it has no for loop. It is for a single record. And therefore, it has already completed its work. The first function was for inputting the data. The second one was for computing scores, and the third one is for displaying. And you can see the last statement here is whose total is 79. That is the last statement in the output function. This one here, whose total is speaking whatever that is stored in the member called sum, who is accessible to the variable called student1. And that's how this program will work. Next is how do we use functions for, how do we pass arrays of functions to structs, or how do we pass structs of array or array of structs to functions? So you can also pass various occurrences of a structure. That's what I'm calling array of structure to a function. It is important to note that just as it is done for arrays, passing an array of structure to a function is done by reference and not by value. So it's my expectation, my dear students and the rest of the learners, that before you proceed with this section, you will go to the presentation in this series for C++, which I have spoken about or taught about arrays, and the other one about the functions, because here we are just combining the knowledge from the two. So the same way we pass arrays to functions by reference is also the same way we can do for structs. But note, it is important to note that just as it is done for arrays, passing an array of struct, what we are talking about passing by reference is array of struct. But passing the struct itself, the online struct, is by value. In this case, it's a structures variable, that is instance of object that is passed to a function as a parameter, just as we pass other variables. Remember, struct, once you define your structure, that structure becomes a new data type. So you pass to a function array for the object, for the variable, for that structure's variable. Then within the function's parameter list, we make use of our newly created data type, which is the struct, as our parameters data type, followed by the structure's variable with the square brackets to indicate that it is an array. If, for example, you have an array of struct declared within the function as follows. So this is an array of structs. It is composed of a structure variable called students and the number or its number of elements are 5. When I talk about elements are the occurrences. I can also call them the records in other ones. So if you have that, meaning that the struct student scores has been defined with a global scope, then we can pass the array of struct to a function such as one for getting data by the name get data as follows. So you can see what you're passing is the variable for the structure. That's what you pass. And our variable is, structure variable is students. So we are passing students to get data function. So the function prototype that would receive this array of struct as a parameter will look as follows. So we are passing to it, to the function called get data, the structure variable called students. And this structure variable is of type array. And therefore, we are passing students. You can see what is enclosed in the parentheses is the array called students. But of what type? The type is struct student scores. So this function called get data does not return anything. That's why it is void. But it is receiving one parameter which is of type array of struct called students. And its data type is struct student scores. From there, we have to make use of the for loops to access and process each of the structure members through their respective structure variables. The following is therefore a sample program implementing passing of array of struct to a function and processing the struct as required. So the name of our program is struct array passing. It implements passing of array of struct to a function. The other parts are as usual. Then we define our structure here. So we have struct, our structure is called student scores. And then it has members as follows. These are the same members we have been dealing with. And because we are going to have the variable structure or structure variable being local, that's why we are not having it as part of the structures definition here. And then because we are going to be storing cumulative sum of all the students, that's why I have included a global variable called overall sum, which is supposed to hold data of type integer, and I'm initializing it with 0. Then the functions prototypes, because the definition for our functions will be after the main, are as follows. The first one is for function called get data, which is not supposed to return any value, but it is receiving one parameter, which is of students, which is an array of struct on students, and the data type is struct student scores. The second function is complete sum. It's not supposed to return anything, so that's why it is having data type, return data type being void, but it is receiving a parameter. It is receiving a parameter, which is a student, which is of type struct student scores. Just as I said other functions, you may omit the specific name of, you may omit the specific name of the function, or not of the function, but of the variable. But ensure you tell the compiler what type of data is that expected variable supposed to hold or accommodate. That's where you can see the difference between this one and this one is that the second one has not included the name of the variable, but the type is there. Then the other function is called display data. It's not expected to return any value, but it is receiving one parameter called students, which is of type array. That is a structure variable of type array, and its data type is struct student scores. Then from there, we go to main. Then here, we declare our array instances of variables. Now, not array, but our structure variable. Now, our structure variable here is called the students, and it's an array of struct of type student scores, meaning of type structure, and the structure is the structure which is called student scores. Then the first statement to be invoked is for the function called get data. What happens? Now, this function get data is being invoked and being passed to it the array of function called students. You can see we don't use the subscript in the argument. We are only having the variable name, which of course we know is of type array. So once the function called get data is invoked and it is receiving the structure variable called the students, then the compiler will go to that the function prototype, find out whether it is there, find out whether it is there. Here it is. It's supposed to receive that parameter and not return anything. So it will go and look for that function after main. Where is the definition for that function? Where is the definition for that function? Here it is, prompting user to enter data. So this function is now having the for loop because we are going to read members of several students. So how will it work? Yes, I have seen this for loop will work. It will first initialize student num to 0. Check if the value of student num is less than 5. If it's less than 5, meaning this is the index for the first student, it will perform all this. It will accept the name and store it in the student 0. Com score, store it in student 0. That means all what will be entered for the first round up to there is for student 0. Then increment student num to 1. That means execute the last part of this for loop statement. So increment the value of student num with 1. So 0 plus 1 is 1. Is 1 less than 5? Is student num less than 5? If yes, it will then read the student name for the first student, whose student num is 1. So students 1, the student name, and proceed with all the others up to students 1 OOP score. Then increment counter again, execute the last part of this statement here, increment the value of student num with 1. So 1 plus 1 becomes 2. Is 2 less than 5? Yes. Perform the following. And that will continue, that iteration will continue until the value of student num is not less than 5. And then come out of that loop and return control back the caller who is main. So let's go back to our main program. We go back to our main program here. So after completing the processing of function called get data, it will invoke the get. The next is the function called compute sum. So this is an invoking statement for the function called compute sum, which is going to receive the value of the variable or the students, the array of struct. So we go to compute sum, we find here's the prototype for compute sum. Then we go to that function definition after the main function. Here we are. So this function is receiving the array of struct called students, and is of type struct student scores. So it will here it has a local variable called student name, which is counter. The counter is being initialized to 0, and the process will continue just as I have said. It will pick whatever is in student name, that is, I repeat, it will initialize student name to 0, check if the value of student name is less than 5. If yes, it will do what? It will proceed. It will proceed and compute. It will compute the values here. It will compute the values. It will compute the values. First, when student name is 0, it will read OOP score. Assign it student name 0. Do the same for month score. Read whatever is stored in memory location or in the member called month score for student 0, and what is in SIS score for student 0, and to CS score for student 0, and to COM score for student 0. Then the overall, the total, assign it into or store it in the memory in the member code student 0 dot sum. So store in the member code sum for student 0. Then from there, I pick what is in student name sum, like student 0 sum, and add it to what is in the overall sum memory location. And the results, assign them back to the memory location called overall sum. Then write out a new line. And then once it executes this statement, it will increment the for loop. So increment the value, not the for loop, but increment the value of counter. So student name will be incremented with 1. So 0 plus 1 is 1. Then check, is 1 less than 5? Yes. Repeat that. Pick what is in student 1 member code OP, and it what is in students 1.math score, and what is in students 1 SIS score, and continue that way. And the overall score, assign it to students 1.sum. Then pick what is in student sum 1, and what is in the overall sum, and what is in overall sum. And then the overall results, assign them back to the memory location called overall sum. Write out a new line, then increment the value of counter again. Increment student name with 1. So 1 plus 1 is 2. Is 2 less than 5? Yes. So repeat this, and the process will continue until the value of student name is not less than 5. Once it's not less than 5, that loop will be skipped. So this part will not be executed. This part here will not be executed. This part will be skipped, and the control will be taken back to the main program. So it will go back to the caller here. So the next function will be to invoke display data. This function is going to receive the argument called the students. So the argument called the students. So the compiler will go to prototype, find it is there, and then because already it is being made aware that there's a function called display data, which is receiving a parameter of type students, a parameter called students, which is a struct of array, and is of type struct student scores, and it's not supposed to return anything. It will go and look for that function at the end of the main. So here is the function. So the parameter called students array of struct by the name students will be received here, and then there's an initial variable being declared here. There's a variable, local variable being called or being called student name, which is a local variable. And then it will now display this message on the screen. Write out these headings as it displays them as guided, and then I'll start reading what is in the struct and writing it out using the for loop, as you can see. So it will display all of these values. It will read each of them. For student name 0, it will write all of them, increment the counter 1, then repeat this, read all what is in student num 0, student, or what is in student 1. All the members of student 1 will be read. Then once this brace is reached, it will increment the counter to 2, write out all the values for students 2, index 2, all of them, then increment the counter, write all the values for students 3, that is index 3, increment the counter, then write out all the values in the member of student 4, then increment the counter. 4 plus 1 is 5. Is 5 less than 5? No. So all this part will be skipped, and the compiler will write out this statement here. To display the statement, the cumulative thought for the students is pick what is in the memory location record overall sum, write it down, and drop down or write down a new line. Then return the control back to the main program. So it will come here. It will go back to the main program, and then it will execute this statement. Take the control back to the operating system and end the program. So that's how this program will work. Let's now see, how the output will look like in our main program. So what we are going to do, remember our program is called, the name of our program is struct array parsing. So we are going to start our C++ program as usual. Let's close this program, which is open. Start a new program, a new project, and a new program. We are going to call it what? Struct array parsing. We call it struct. We are going to call it struct array parsing, because you are passing an array of struct to a function. And then, of course, we right click here, new item. We are writing code for C++. The name of our source code of our file, the name of the file is struct array parsing. And then we click on, and so we are now just going to copy our program. We shall just copy our program. Here it is. We shall just copy this program. We just copy this program, paste it in our editor, just as it is. And then we save it. We build or we compile our program. Once we compile our program, we can see the results. It has been successful. So we can run our program. We click on debug, start without debugging. So this program is similar to the other one for array of structures. The only difference is that in this one, we have modularized it. We have broken it down into functions. So I will not really explain much about how it is working now, because I've already explained. So already we in the first student. So when student number is 0, we are going to enter data for first member, first student. So you can say name is mem, and you enter scores for each of them as listed there. Then the counter is incremented to 1. So student number 1. So we enter a name like Agnes. Then we key in the values for that student. Then counter is incremented to 2. So we are entering student whose index is 2, the structure. So for this student, Otieno. And then we can enter the scores for Otieno, just in the order. Then counter is incremented to index 3. So we're entering details for the fourth student. So the name can be Mary. And then we can enter the scores for Mary. And then the counter is given to 4. So we enter the 4th student's information. So the name in this case can be Salat. Then we enter the scores for student whose index is 4. You can see that once that has been done, the next function that has been executed is for computing the total, because you can see total at the bottom here. And the function for displaying the results has been executed. So the function for displaying the results has been executed. And the output, as you can see, is formatted, and the total is here. And that's how we modularize a function for passing structs to arrays, or in other words, for passing array of structs to functions. That's how we modularize. We modularize a program using functions, and functions that receive an array of structs. And therefore, my dear students, and the rest of the learners, you have seen how the output for this program looks like. Remember, you can always copy this program, write it on exercise books, code it in your program, in your computer, execute it, and key in the output just as you have seen. And therefore, with that, we have come to the end of this series, or this part of the series. We have not come to the end of the series, but we have come to the end of part 10 of the series. You can continue to part 11 of the series, in which we are going to learn about pointers. Congratulations for learning part 10 in C++ computer programming series by the title Structures. You can access the rest of the parts in the series, as well as other computer or ICT videos, by clicking or tapping on Emediswap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. Remember, you can also now join Emediswap ICT as a special person by clicking on join button in the video, or that is appearing directly on the video next to subscribe button. For any further correspondence, kindly write to us through the email emediswap@gmail.com. Thank you very much for listening to me. Let's meet again in part 11 of this series, and God bless.